Hello everyone and welcome back to chemistry. So this is going to be the introduction to the first topic of term 2 for unit 1 chemistry. And before we start, I thought it might be worthwhile to just give you a quick recap of what we did last term. So term 1 was the introduction to chemistry for a lot of you. I know you did some chemistry in junior science, but really we started by looking at atoms and periodic tables and mass number and atomic number. So all very basic stuff. And then we really, well, year 11 chemistry really takes off when we started talking about bonding. So that was the focus of the last SAC. So we have metallic and ionic and covalent. And I think covalent bonding, for me anyway, is the most interesting topic with the largest variety in terms of types of atoms that can form covalent bonds and the types of covalent bonds that you can have, the combinations of covalent molecules that you can have. And then we also look at intermolecular forces. So that's bonding. So that's where we ended with term 1. I don't think we actually did that much content if you think about it. But we're going to look at this term, at least for the first 4 weeks or so, is an application of these two, which is covalent bonding and intermolecular. I don't know why. Well, you can write bonding and forces. An application of covalent bonding and intermolecular forces in the context of materials. So what we're going to look at in the first 4 weeks is an introduction to organic chemistry. Now, the definition of organic in chemistry is it is the study of carbon-containing compounds. They are all covalent. So organic chemistry you can think of as an example of covalent molecules and also covalent lattices if we have time to get to that. So any compound or even molecules that contain carbon is considered an organic compound, with the exception of carbon dioxide, the carbonate salts, maybe some other organic compounds that you don't have to worry about too much. So the terms organic has multiple meanings, but in the case of chemistry, it's just anything that contains carbon, with some exceptions. So we would be considered organic compounds. And a lot of other products around you would also be considered organic compounds. So I think this is a very good opportunity as well, given the current climate, for us to really study one organic compound in a lot of details, or a product, an organic product, if you will. It's a combination of multiple compounds. So I think in the next 4 weeks, we're going to look at organic chemistry, specifically in the context, oh yeah, don't worry about this, of this product, which is something that I'm sure you have heard of if you follow the news at all in the last month. And this is the N95 mask, which, well, I followed the news and I had to wonder exactly how this product is made and why is it so difficult to make more of it. So what actually goes behind the process of making N95 mask? Now, I know for a fact that this is an organic product. All materials, right? Except for, say, I think that's the aluminium. Everything else is organic. So I looked at the materials. Now, this is the N95 mask made by 3M, which is one of the largest providers of N95 mask, which, fun fact, is also the Sticky Note company. So the Sticky Note companies make N95 masks. That was one of the things I learned in the last few weeks. But if you look at the materials for this mask, so you have some metal in the nose clip and the staples, but everything else. So you have polyisoprene, polyurethane. I can't even pronounce it. Polypropylene. This is the filter. So this is the thing that we're going to focus on, and then you have polyester. All of these, this one, this one, this one, this one, this one, they are all examples of organic compounds. So I think we're going to look at specifically this one, which is the mass really is the filter, which is the polypropylene. So let's think about polypropylene. So hopefully by the end of this unit, you can answer the question of what is polypropylene and how is it made, and maybe we can also go into some of the reasons why it is so difficult and time consuming to make more of these masks. But before we start any of that, we need to look at the names. And I don't know whether you notice there are some similarities between these names. So these two end with E and E. These two have the same name. Does that mean they're the same materials? And everything starts with the word poly. Okay, so the word poly must mean something very, very specific. So I'm just going to tell you right now that when you look at polypropylene, it's not the best name. This is using an old notation. The scientific name for this is actually polypropene, but the propylene is just kind of stuck. And there are actually two parts for this name, the poly and the propene. Poly just means that it is a polymer, and we're going to talk about what a polymer is in a lot of details. But I think this lesson, we're going to focus on propene. What is a propene and how do I know what it is based on the name? So we're going to look at this for the first week, and then we'll look at polymer later, and then we'll look at some other things. All right, so that's the introduction. I need to stop this video. How am I supposed to